This lecture will explore cryptography from a mobile perspective of what is needed in a mobile society to keep data safe. Much of the communication today is conducted from mobile platforms, so it is important to understand the capabilities that exist in this arena, the applications that can be used to shore up any gaps, and the overall security posture of the devices that are most commonly used. Anyone in a first world country today knows that the use of mobile devices has increased to the point that almost everyone in these nations has a device that can access the internet in some form or fashion through mobile technologies. Now, these advancements have brought about an unprecedented level of communication capability, as people are no longer tied to landlines to make phone calls or to desks to access internet capabilities. Statistics show us that anyone in the United States that wants a cell phone has one, and that single device today tends to be the device people use the most to access their online content, especially the content that is more of a personal nature, such as social media, email, and banking activities. Add to this the many public access points where users can connect to free wireless internet routers and sit in coffee shops or restaurants while they type feverishly away on their laptops. It is a mobile world, and a mobile world without encryption is a dangerous world. The first thing we need to think about when discussing mobile encryption capabilities is that these capabilities need to be equal to the capabilities available on their non-mobile counterparts. Whatever encryption standards can be applied to fixed systems need to also be applicable to devices that can be used in a mobile fashion. Now, the nice thing is that a laptop can be used in a fixed or mobile way, so that technology easily carries over. And a smartphone is really nothing more than a small computer that, in many cases, runs different versions of the same software. So once again, porting cryptography into this arena is pretty straightforward. And when we look at the common applications that are used, such as email and internet, the protocols are also the same. And many of the apps we use on smartphones use the HTTP or HTTPS protocols, so essentially we have a lot of web-based traffic that needs to be protected. But where the issue gets murky is how each one of those apps is handling the encryption. If your banking app doesn't secure the connection, all your financial data will be sent as clear text. Now, that could potentially be passwords and account numbers. So we have to have a way to be sure this content is encrypted. In the world of cryptography, clear text is dangerous. Users should want to encrypt as much information as possible because even a little bit of private information leaked out over time can paint a picture that allows a criminal to construct the private information you are trying to keep secure. But we also have to look at the wireless connections that we use. Public Wi-Fi is usually encrypted, but the cellular connection from your phone network typically is not. So encrypting the data before it is sent is a priority. Now let's take a closer look at smartphones and the capabilities that the three most common providers include in their software. Android, Apple, and Microsoft all have encryption capabilities to secure the data on the phones. But the way that encryption is implemented is a little different for each. You may have heard about the FBI's legal attempts to force Apple to break into the iPhone of a criminal. Now, this entire case centered around the topic of encryption. We'll discuss this in further detail during another week, but for now it's good to understand that the encryption implemented on that particular phone posed a big problem for someone trying to decrypt the data. Apple's operating system version is configured so that if the user encrypts the data, Apple does not have a backdoor to break into the phone. The security of the device goes back to the user keeping the password or PIN code secret. The latest version of the Android operating system falls into the same category. In both of these systems, if a criminal steals your phone, they will not be able to access your data. Now, this is the core reason for cryptography, to keep your data safe. But it also means that law enforcement won't be able to break in either, so it does give criminals a potential upper hand. Now, more on that topic in a few weeks. The Windows operating system is a little different. Microsoft servers still hold a copy of the encryption keys for your phone, so theoretically, they could hand the keys over to a government organization if a warrant is issued. And if those servers are ever compromised, a criminal could also access those keys. So for now, it seems that the iPhone and Android devices are better for protecting a user's data. Now let's shift to another common technology that most phone users utilize: text messaging. You may not be aware of this, but text messages are sent as plain text. This is because text messages are actually sent as part of the communications protocol that allows the phones to communicate on the network. It is the same reason why these messages are truncated to 140 characters, because that is the maximum amount of space available in the protocol field that they are stuffed into. But because they are plain text, anyone from the phone company can read your messages. And anyone else siphoning data from public communication lines, such as intelligence agencies, can also see your messages. So again, we have to think about the cryptographic content that clear text is dangerous. How much information does a person send via text messaging every year? If I collected all of this data, could I correlate any secret information? I could certainly gather phone numbers, addresses, names of friends, important dates, and probably even some passwords. All of this information could be enough for a criminal to log into an account that would otherwise be secure. Now, we often take the perspective of not having anything to hide, but oftentimes there are small bits of information that, when combined together over a long time, will provide detailed secrets. This is why the intelligence organizations love to gather a lot of information. They know that they can construct a much clearer picture over time. Now, I don't say this to make you paranoid or to speak negatively of the intelligence organizations, because they do have an important job. But it doesn't mean you can't secure your data. Fortunately, there are some applications that can secure even your text messages, and many of those applications are available for the common smartphone operating systems. The Signal Private Messenger is one application that I personally use. It encrypts all text messages between any phones that use the service. It sends the messages through the data portion of the phone's network connection instead of using the protocol technology mentioned earlier. And one advantage of this app over others is that the company also does not store copies of the keys, so the user is protected in a similar way as with Apple and Android phone encryption. CyberSafe is another handy encryption application that can provide an additional layer of security on smartphones and essentially creates a digital safe to place documents into. Now, this can be used in addition to the cryptography already on the smartphone, and can also be used to encrypt data stored on Google's Cloud Drive location. Now, that last piece is a big plus, because being able to store data in the cloud in an encrypted format is an implementation of this technology that has not been widely adopted. The final area I want to discuss in this lecture is that of the popular ability to make payments at many stores by simply tapping your phone on a payment device. Now, the technology behind this is known as near-field communications, and we won't discuss that here, but you can read about it online. The idea, though, is pretty simple. A user stores their payment information in their phone. Then, when they make a purchase, the phone provides the information electronically, so the user never has to take out their wallet or use a physical medium to make the purchase. But is this safe? Well, yes, it is actually safer than using a physical card. The data provided to the merchant is actually less than what they would normally receive from a physical card, and the card number is mathematically generated at the time of purchase and is only good one time. This means that if criminals hack the payment system, they won't be able to steal your card information. Now, the other question is whether or not it is secure. On the phone itself, the card information is supposed to be stored in an encrypted state and protected by a fingerprint reader. Some early implementations weren't very good, but it seems that the latest iterations are well stored. But the card is also stored on Apple or Google's payment server somewhere. Google has the Google Wallet app, for example, and the data there should also be encrypted, but then Google employees may also have access to that information. Cryptography exists to keep data safe, and the technology exists today that we can keep all of our data safe, whether that is on a physical device that never leaves the office, a mobile device that we take with us everywhere we go, or the common data that we send across the airwaves every day. The need to implement this technology is well known, and encryption capabilities are implemented in many needed situations. We also need to keep an eye on future capabilities that may weaken encryption technologies and on future ciphers that may be even stronger than the ones currently available today. As new technologies are developed, we will need to adapt the current capabilities to protect those technologies as well.